right, so to continue on our examples, we're going to do another rational equation, which means it's an equation that has variables in denominators. So I have a 6y over y minus 2, and that is minus 12 over y plus 2, and that's going to equal 48 over y squared minus 4. All right, so first of all, what do we need to do? We need to restrict our domain. So restrict the domain. So that means I'm going to take each denominator and say you better not be 0. So y minus 2 cannot be 0. Add 2 to both sides. We better not generate a 2 for an answer. If we do, we can't use it. Okay, y plus 2 better not equal 0. So subtract 2 from both sides. And so if I generate a negative 2 for an answer, I can't use it either. And then finally, I got y squared minus 4 cannot equal 0. I'm going to add 4 to both sides. And I'm going to take the square root. So y cannot equal plus or minus 2. That's really messy. Let me rewrite it. So I've got y squared minus 4 cannot equal 0. I added 4. So y squared cannot equal 4. I don't care what y squared is. I care what y is. So to kill a square, I take a square root. Anytime during the process of solving a problem that you take a square root, do not forget your plus minus. I know what the square root of 4 is. It's 2. Okay? And it's a positive 2 or a negative 2. So I've already stated y cannot be 2. Y cannot be negative 2. Y cannot be negative 2. Y cannot be 2. So I've restricted my domain. My values cannot be negative 2 or positive 2. They are off limits. Okay, now if you factor this, you get y plus 2, y minus 2. This is the difference of two squares, which means my common denominator, I need a y minus 2. And there's one in here because I factored it to be y plus 2, y minus 2. Because it's the difference of two squares. So I need a y minus 2 for a common denominator. This one already has it. I need a y plus 2 for a denominator. This one already has it. So my common denominator would be y plus 2, y minus 2. And then remember that I'm actually asking you, it's just easier for me to say what would your common denominator be, but what I'm really asking is what's the least common multiple, because that's what we're going to multiply through by. So I'm going to rewrite. I've got a 6y over a y minus 2 minus, well, poo, okay, minus 12 over a y plus 2, and that needs to equal a 48. And I'm going to go ahead and write this in its factored form, which is y plus 2, y minus 2. So y plus 2, y minus 2. So now what am I going to multiply through by? I'm going to multiply through by y plus 2, y minus 2. Y plus 2, y minus 2, y plus 2, y minus 2. So I'm changing what it looks like. I'm not changing what it is, because I've multiplied everything through by the same thing. So my y plus minus 2's, reduce. So that leaves me with a 6y times y plus 2 minus 12, and then my y plus 2's reduce. So that leaves me with a y minus 2. And then over here, the y plus 2's and the y minus 2's reduce. So that leaves me with a 48. Okay, so again, what I've done is just rewrite into something that's easier to manhandle. So what do I know how to do? I can distribute, so plus 12y minus 12y plus 24 is 48. So I distribute everything. My 12y minus 12y reduces, okay? And so now I've got a 6y squared plus 24 equals 48. So I'm going to subtract 48 to both sides. How do I know to do that? Because I know I'm going to start factoring. I got to figure out what to do. Okay? So if I set it equal to 0, it'll help inform me about what my next moves should be. Okay, so I've got a 6y squared, and then minus 24 is 0. Well, now everything's divisible by 6. So I'm going to divide this by 6, this by 6, and this by 6. Remember, I can do anything I want to as long as I do it to the entire equation. So that leaves me with a y squared minus 4 is 0. So now I can either factor and set each factor equal to 0, or I can add 4, which I would rather do. So I get y squared is 4. So square root both sides, so y can be plus or minus 2. Anytime during the process of solving a problem that you have to take a square root, do not forget your plus minus. So I've got two answers. One is positive 2, one is negative 2. Check. I can't use them. They are both extraneous. They are both extraneous. So your solution to this is the empty set. There is nothing that will make this thing work. Absolutely nothing that will make this thing work. All right, so let's try another one. I have, oops, I almost knocked over my T, 6x over x minus 6 equals 9 plus 7x squared over x minus 6. So this is a rational equation. I need to restrict my domain. So my denominators match already, except for this is over 1, but we'll handle that in a second. So to restrict my domain, I'm going to take the denominators, which they match, so I actually am saving time this time, and say u cannot be 0. So add 6 to both sides. I cannot use 6 in my answer. Cannot use 6 in my answer. Okay, I don't need to do this one because it's just going to do the same thing. So I'm saving time. All right, so rewrite the whole thing. If you needed a common denominator, what would it be? It would be x minus 6. Okay, so I'm going to multiply through all three chunks by x minus 6. So I'm going to multiply this chunk by x minus 6, this chunk by x minus 6, don't forget him, okay, and this chunk by x minus 6. So any number divided by itself is 1. So this is going to leave me with a 6x equals a 9 times x minus 6 plus a 7x squared. Okay, so I'm going to go ahead and start doing stuff I know how to do. I know how to distribute, so I'm going to get that done. So I've got a 6x equals a 9x minus 54 plus 7x squared. Okay, now I see a 7x squared and he's positive, so I'm going to bring everything over to him so I can start factoring. So I'm going to set it equal to 0, but instead of putting my 0 over here, I'm going to put it over here because that means my lead coefficient will be positive. So I've got minus 6x, oops, sorry, minus 6x. So I get 0 equals, and now I'm going to put it in descending order. So 7x squared, 9x's minus 6x's is negative 3x's, and then I've got a minus 54. Okay, so what do I need to do at this point? I need to factor. So we're going to do factoring by grouping. So I need two numbers that multiply to 7 times 54 is going to be a negative 378. Is that right? Negative 378. Don't even know. Hang on. So, calculator. I got a 7 times a negative 54. Holy cow, it's 378. All right, so here's the deal. I'm a lazy math person, and I usually try and avoid the quadratic formula as much as possible. But for me to start listing factors of 378 is going to be really, really irritating. So even though it's going to be a little bit more analytical, I can get the right answer by using quadratic formula, and that'll take out all the guessing and checking. So I'm going to use quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is my a, my b, and my c in descending order. So I've got x equals negative b is going to be positive 3, so negative 3, plus or minus b squared is negative 3 squared, which is 9, minus 4 times a times c, all over 2 times a, which is going to give me a 14. So in my calculator, I'm going to do 9 minus. Let me turn down my screen so you can see what I'm doing. All right, so in my calculator, hang on, I just dropped everything. I can't do it. All right, calculator is going to give me 9 minus 4 times 7 times negative 54. So 9 minus 4 times 7 times negative 54 gives me 1521. So I've got 3 plus or minus the square root of 1521 over 14. And now, is that a perfect square? So the square root of 1521 is 39. Okay, so I found, since this went pretty, I knew it was factorable to start with. I just didn't want to waste my time trying to figure it out. So I now have 3 plus or minus the square root of 1521 is 39, all over 14. So that gives me 3 plus 39 is 42 over 14. 3 minus 39 is negative 36 over 14. So 42 over 14 reduces to 3. And then negative 36 over 14 is going to reduce by 2 to give me a negative 18 over 7. Okay, so you have 2 answers. Do not forget to go back up and check. Am I allowed to use it? The only one that's off limits is 6. I didn't generate a 6, so I've got 2 answers, 3 and negative 18/7. Okay, so let's try another one. All right, so we have, actually that's a good place to stop. So I'm going to pick up in a third video and we're going to do the radical equations.